So we'll be starting with the new unit, that's data acquisition systems. So data acquisition systems have actually seen a rapid growth over the past few decades, and owing to the improved processors, semiconductor technology, etc. So all those systems have resulted in a new and better form of data acquisition systems. Now, what is a data acquisition system? It's simply a measurement. You can say it's a system that's used for measurement that will be used for measurement and for recording signals. So these signals can either be obtained from direct measurement or two, they can be obtained from transducers. So a complete system that actually helps us in the measurement of as well as recording the signals, analog signals rather, arising from direct measurement, like say for example voltage from a voltmeter, current from a ammeter, or signals that are arising from transducers, measuring them and recording them. That's what a data acquisition system basically does, broadly speaking. Now there are two types of data acquisition systems. One, you can have an analog system, and another one you can have a digital system. So as we understand, the analog systems will basically deal with the information in the analog form, while as the digital systems will deal with the information that may be in the discrete domain, or you can say the digital domain, and the magnitude will be varying discretely with respect to the time. So data acquisition systems, they are in broadly speaking, they are used for the measurement of and for recording signals that arise either through direct measurement or via the or through transducers, or it helps us in measurement and recording of signals that actually are derived from transducers. So this is a broader definition of a data acquisition system. Now we can have either an analog based system or we can have a digital system. Now what are the components of a data acquisition system? Components of a data acquisition system. Now we are actually dealing with analog devices, analog data acquisition systems. First of all, we'll be seeing what will be the components of both the digital system as well as that of the analog system. So first of all, the components of the analog system, and there are a number of components. Listing them down, first you have the transducers, you have signal conditioning equipments, Uh, so you can have different components. You can have transducers, signal conditioning equipments, calibrating equipment, the integrating equipment, the visual display devices, analog recorders. You can even have analog computers, and maybe a display unit like a TV, uh, something like that, or even cameras for that matter. Uh, so all of these form a part of a data acquisition system. Now we have already studied transducers in details. We know basically that transducer simply converts one form of energy into a measurable form of energy, that in our case mostly is an electrical form of energy, and we have studied different types of transducers as well. Now as far as signal conditioning equipments go, there will be equipments like amplifiers that will help us actually condition, or they can help us better transform the output of a transducer to desired magnitude values, or to any form that's actually acceptable to the data acquisition system. So again, we have studied signal conditioners, so they can also amplify the output of your transducer into a more measurable, into a more readable form for the system. And you can have calibrating devices, calibration for calibrating the system. You can use these equipments so that your volt, you might measure a say for example you are trying to measure position but in the form of voltage, so calibrating the position with respect to the voltage, seeing how the proportional change between the voltage and the position is taking place. So accordingly we'll have to calibrate the device so that each position or each voltage measurement gives you the equivalent position measurement as well. So you can have even integral equipments for measurement of for summation or for integration of any quantity, so that you can get a measurement of the device over a longer duration of time. Or if you want to find out the average of any output, you will try to integrate it over a period of time, you will try to sum it over a period of time. So using different techniques, using different equipments, you can actually go for integral and get a time integral of the measured quantity. Rather than just getting the instantaneous value of the quantity, you can get the time integral value of the quantity. And then you have the visual display devices. These will include the CROs. They can be single channeled or multi-channeled. So CROs, basically what they do is simply they help us view the waveforms extra on a screen, through which we can both measure as well as monitor the waveform that's being measured. Then you can have recorders. Recorders can be of different types. They can be simply magnetic tape recorders, they can be strip chart recorders, or you can even have a CRO with the memory inbuilt, so that or so that this data is recorded at some place. Then you have equipments like analog computers or digital analog cameras and TVs. So again, for performing various operations, various computational operations on the output of this very particular data acquisition system, we can use an analog computer or different computation techniques, so that your system becomes more accurate as compared to what it is. And similarly, if we want to monitor our output, we can use cameras. If we want to record or display anywhere, we can have TV extra. So these equipments do not form a necessary part of the data acquisition system, but they can be used with the data acquisition system as well. So you basically have different devices. You can have the transducer, the signal conditioner, the calibrating equipment. They form the and the display devices. They are actually the main parts of this data acquisition system. Apart from that, you can have the integrating equipment, the analog computers, the cameras, and the TVs. This was about the analog data acquisition system. Now, what will be the components of a digital uh, data acquisition system? We'll have to actually study all of these components one by one. So you have almost the same types of, you have the same components, the transducers, the signal conditioners, but apart from that you need to have an interface for digital to analog communication. Uh, you have multiplexers, you have ADCs, you can have then now your recorders here will be digital recorders. So you have all of these devices. You have the transducer, the signal conditioners, extra. Apart from that, for interface between A to D, you need the ADCs, you need digital recorders. Now here you need digital printers, and you might need some other auxiliary equipments, and these equipments can be used to perform certain functions like amplification, linearization, uh, saturation, extra. So you can have different devices. I'm writing DAQ. DAQ stands for Data Acquisition System. Now, what is the use of data acquisition system? Why do we use a data acquisition system? And so we so you know already the advantage of digital devices or analog devices, so where we can use digital devices as compared to analog devices. Now, what is the use of data acquisition systems? Data acquisition systems find a lot of use in telemetry, in biomedical instrumentations, in aerospace technologies. Say, for example, in power systems, we have SCADA, supervisory control and data acquisition. So we try to gather, we need the system to gather information about a we need to gather information about a large network, number of substations, number of grid stations, the generating stations, we need to have an information about how the system is behaving, where the system is down, where the system is running up, and how the system has been performing over a number of days, what has been the power forecast, what is not the forecast really, what has been the load on the system in the previous few months, previous few years, previous few days. So we need all this information, and the system that actually can accumulate a large number of data, measure this data as well as record this data. It's a huge chunk of data. We need a proper measurement instrumentation for this, and that system is nothing but what a data acquisition system does. It collects a huge chunk of data and stores it. It's not just used for instantaneous measurement of any voltage or current. This will be used particularly in applications where you need to store this data for a period of time, for where you need this information over a longer duration of time. You need to monitor a large network. So all these application areas, be it power systems, be it telecommunications, be it biomedical instrumentations. So you have biomedical instrumentations, you have telecommunications, you have power systems, extra. So these type of applications require that a measurement require a measurement tool that can actually accumulate this data and keep that stored for processing for later as well. And apart from this, you can also use data acquisition systems for interface between analog and digital devices. We know, as I said to you, the first thing, we have the advantage of digital devices. It's immune to noise, it's more sensitive, it's more user friendly, and all of these as well as there will be a more bandwidth, more frequency range within which the accuracy and the tolerance will be better as compared to its analog counterpart. So digital devices also use data acquisition systems, and say for example we need to control robotics, or we need to control any large motors in industries, and or in any research station. These motors, these interconnected networks of different drives can be controlled using one data acquisition system, wherein it can gather information from all the systems and provide the feedback mechanism as well. And so that's the use of data acquisition systems, applications rather. And we actually now have different types. We have to study different types of these different components, the recorders, the signal conditioners, multiplexers, all of these things. So that will start in the next session, hopefully, inshallah.